सो हेलो गाइस, वेलकम बैक टू अवर चैनल। हमारा गुरुकुल चैनल पर आपका स्वागत है और हम आज आ गए हैं एक नए फॉर्मूला के साथ जिसका नाम है लिगेंड्रेस फार्मूला। सो लेट्स गो टू द क्वेश्चन। द क्वेश्चन इज द लार्जेस्ट नंबर n such that 3 to the power n divides 50 factorial. Now, this question was asked in JEE Mains exam conducted on 2nd April 2025. So the option were 20, 21, 22 or 23. So what this question says actually? The problem asks for the largest integer n such that 3 to the power n divides 50 factorial. In simple terms, we can say how many factors of 3 are hidden inside 50 factorial. So what does factorial actually mean? The factorial is a product of all the integers from 1 to that number. In this case, that number is 50. So 50 factorial equals 1 multiplied by 2 multiplied by 3 till 50. Now what does divide mean? It means you can divide 50 factorial by 3 to the power n and get a whole number with no remainder. Means we can say 5 divides 10 because the remainder is 0 or there is no remainder. But we cannot say 5 divide 12 because there is a remainder, that is 2. So 5 don't divide 12. At the end we should get a whole number, not a decimal number. So we need to find what is the largest integer n such that 3 to the power n divides 50 factorial. Now why are we talking about largest integer? In the exam they can ask for the smallest integer also. But why largest n matters? Why smallest n do not matter that much? Because it's easy to find the smallest n. Why? So let's take n equal to 1. Does 3 to the power 1 divide 50 factorial? Yes, because 3 is one of the number in the product. Because in 50 factorial we have many 3's. So let's take n equal to 0. Does 3 to the power 0 divides 50 factorial? Yes, because 3 to the power 0 equals 1 and any integer is divisible by 1. So we can say if we want to find the smallest n that divides any factorial, then it's easy and it is 0. The real challenge is finding the largest n. This tells us the total supply of the prime factors 3 available within 50 factorial. So let's go step by step. So if we will go with brute force method, then we can see first factor of 3 is 3 itself. Then we will go to 6. And 6 is 2 multiplied by 3. Then we will find one factor with 6. With 9, we will find 3 multiplied by 3. That is 2 factors of 3. And we can go like this. But what if the number is too large? Currently it is just 50. In the question it can be too much large. So we cannot go with that way. So next we will find the power of 2 in 10 factorial. We are taking the smallest example to understand the situation. So let's count the factors of 2 in 10 factorial. What is 10 factorial? 1 multiplied by 2 multiplied by 3 till 10. Now 2 has one factor, 4 has two factors, 6 has only one factor of 2, 8 has 3 factors of 2 and 10 has only one factor of 2. So total factor of 2 in 10 factorial is 8. Now if we will notice and we will group all the powers of 2, then we can solve the problem easily. Now how to do that? Like, we will first select all the counts of only 2. Since 2, 6 and 10 has only one count of 2, so here only the total count of dividend of 2 are 5. Like, although all of them, like 2, 4, 6, 8 and 10 has 2. Now since 2, 6 and 10 has only one factor of 2, we will remove them when we will count the dividend for 4. So this time we are dividing by 4 and we are counting the dividends of 4. Why 4? Because 4 has two number, 2 multiplied by 2, 2 times of 2's. We can also say 2 to the power 2. So such factors are 2. We will just count. So one factor is 4, another factor is 8. So total count of dividend of 4, we are getting 2. Now next, since 4 has just 2 dividend, we will remove that. Just 2 factors, since 4 has just 2 factors, we will remove that, and since 8 has 3 factors, in the next time we will count for 3 factors for the 8 and it is just 1. The next count we will also count for 4 factors, but it is not present till 10. So this is the end. So now we come to a fact that total factors of 2 in 10 factorials is 5 plus 2 plus 1, that is 8. Now have you understood anything? By grouping we can make the problem easy. That is the Legenders formula. The core idea is, instead of counting the factors one by one, we count them in organized group or passes. So the solution is, the highest power of a prime number p that divides the factorial of a positive integer n is the floor value of n divided by p plus floor value of n divided by p square, and so on. You must have not understood this formula, so let's go deep dive. So in this case, we have n equal to 50 and p equal to 3. So every multiple of 3, that is 3, 6, 9 and 12 and so on, contributes at least one factor of 3. So how many multiples of 3 are there up to 50? So we are just grouping by 3. So in 50, there are 16 multiples of 3. How we will calculate them? Just 50 divided by 3 and its floor value, that is 16. So the first pass gives us 16 factors of 3. That means in 16 times till 50 factorial will give us 3. Now when we are grouping with 9, that is 3 square, like 9, 18, 27, these number will have 9. So there will be 2 times 3. So we are grouping with 9. So there will be 2 groups of 3 multiplied by 3. So how many multiples of 9 are there up to 50? We can count them as a 50 divided by 9 and its floor value, that is 5. This adds 5 more factors of 3. Now we continue the pattern with higher powers of 3. So now let's say the 3 to the power 3 is 27. So these numbers have a third factor of 3. 50 divided by 27 is 1.85, that gives one more factor. Now 3 to the power 4, that is 81. And this 50 divided by 81 gives us 0.61. Now it's 0 factors. There is no 4 groups of 3 in under 50. factorial. Since the result is 0 at the fourth pass, we can stop. To find the total exponent of n, we can simply add the results of each pass. For the multiple of 3, when we were grouping just by 3, there were 16 factors. When we were grouping by 3 multiplied by 3, that is 9, there are 5 groups. For multiple of 27, that is 3 to the power 3, or 3 multiplied by 3 multiplied by 3, that is 1. So total we are finding 22 factors. So the largest integer n such that 3 to the power n divides 50 factorial is 22. Now, do you have to apply the same process every time? The answer is no. Since you know the formula, you can directly apply it and solve the problem under 30 seconds. Yeah, so the largest integer n such that 3 to the power n divides 50 factorial, we can directly calculate it with this formula. And that's how we will come to the answer, that is 22 in this case. Yay! So we got the answer. Thank you for watching the video. Do like and share it with your friends. हमारा Gurukul needs students like you. Please subscribe the channel. Thank you for watching the video.